welcome to CEC lectures. Myself Dr. Preeti Jagwani from University of Delhi. So, in a previous lecture we have completed the disk scheduling, the topic of disk scheduling algorithms, and today we are going to study about the topic of RAID, or we can say RAID structure, RAID as in RAID. Presently, as you all are aware that we are looking for the improvement, efficiency, optimizations in the disk access. So, disk drive, when we consider that as in our legacy systems or in our earlier systems, there were huge disk drives, we can say. In the earlier days of computers, there were disk drives of some MBs which are to be carried by let us say 2 or 3 person. So, disk drives but now if we can say see our disk drive is actually very compact as compared to the initial ones. So, the disk drive continued to get smaller and cheaper, and because of this thing, because of the kind of size compaction and inexpensiveness, or they are getting cheaper, it is also possible, now it is also possible to attach many disks to a single system. Now, what is going to be what is going to be the advantages of attaching many disks to a single system is all about improving the rate at which the data can be read or written, or we can say these disks can be operated in parallel, that some data is being written on disk 1, another data is being written on disk 2 and some data on disk 3. So, the operation is going on in parallel, and also the read operation similarly. Now, what is actually happening here is attaching many disks gives you the potential for improving the reliability of the data storage along with the data transfer, along with the read and write rates, we can say, because now why the reliability is being improved here, because the redundant information can be stored on multiple disks. So, for example, you have 3 disks. So, on 2 you are on 2 of the disk you are attaching, you are writing some information, and on one which is bigger you are we can say you are writing that information in duplicate, because in order to tackle the situation that if one of the disks is going to be crashed, then the other can be used as the backup. So, the failure of one disk will not lead to the loss of data if we have a backup one. Then for this there are various organization techniques, and these organization techniques are known as RAID structure, RAID, RAID as in redundant array of independent disk. So, these organization techniques in which we are going to either kind of we can say either distribute the data, or we can say we are going to duplicate the data onto many of the disks rather than one. These organization techniques are known as redundant array of independent disks, RAID, and these organization techniques or RAID structures, we can say, are used in order to address the performance and reliability issues. Now, we can see that these RAIDs will have a small and cheap disk, and these can be considered as cost effective alternate to large expensive disk. Now, as I have told you that in RAID it is a redundant array of independent disk, but now earlier the RAID, where it was once stood as inexpensive disk, now it is stands for independent disk. Now, the RAIDs are used for their higher reliability and higher data transfer rates rather than the economic reasons. So, the term of I is being actually changed, inexpensive, also now it is independent. So, redundant array of independent disk, or we can say redundant array of independent disk. Now, how this RAID levels or RAID structure are taken or as considered as a solution to the problem of reliability is they are, we can say they are there to introduce the redundancy. Now, how these are, introducing redundancy? Some extra information that is, not needed normally or in routine, we can say, can be used, can be written on that particular RAID or the extra disk, we can say. And this information which is extra, not needed into the routine, can be used in the event of failure of a disk to rebuild the lost information. Now, here what is that kind of information which I am talking about here is, if you have heard the term parity, parity as in PARITY, parity bits, this is actually a technique in which the parity based bit is stored, and using this parity bit one can come up to this the decision that whether the disk has been, or the data on the disk is, we can say is intact, or it has been disturbed, or it has been lost. So, even if the disk fails, the data are not lost because of this extra information, or we can say one example of such extra information is parity bit I have told you. So, even if the disk fails, data is not being lost, data can be kind of we can say data can be renewed or regenerated with the use of that extra information, which is kind of parity bit, and others can be there. So, for the storage of that extra information, you can use some RAID disks, we can say. Now, when we talk about introduction of the solution to the problem of reliability, and we are going to introduce redundancy. So, then there are kind of two concepts come up, one which is known as mirroring, and another one which is which is known as stripping. So, mirroring, as you can as you understand the term mirror, it is there to introduce the redundancy, that is in we can say each and every disk has to be duplicated. So, in mirroring technique, what, let us say you have 4 disk drives. So, in mirroring technique you will be having 8, 4 the original ones and 4 which can be used as the backup. So, basically with mirroring we can say a logical disk consists of 2 physical disks, and every write is carried out on the both the disks. So, for example, disk 1 and disk 2 are there. So, whatever write operation is being carried out on disk 1 will be carried out also on disk 2, and the result disk 2 is actually will be a mirrored volume. Now, what will happen? Let us say the disk 1 is going to fail, or any one of the disk in the volume fails, the data can be read from the other, and hence with the introduction of redundancy we have achieved reliability. So, data will be lost only if the second disk fails before the first failed one is replaced. Though the one is already failed, and before it is replaced the second one also has been kind of failed, then only your data will be lost. Now, with disk mirroring, what is happening is the rate at which the read request can be handled is doubled, because the read request can be sent to either disk, or if it is a a read request, there are couple of read requests that can be redirected to the different disk, but this will not happen with the write, because write has to be taken place on both of the disk, one on the original and also on the copy, or we can say the backup data. So, the read request can be sent to the either disk, and hence read request can be handled we can say with a double pace, but the transfer rate when we are writing is actually going to be the same. Now, if we talk about mirroring, we have seen that the entire disk has to be duplicated, or entire disk has to be backed up, and every write will be will take place on both of the disks. Now, we have another idea of stripping, in which there is improvement in performance via parallelism. That means we are going to give something in parallel, and then the performance improvement is achieved. Let us try to understand how this is happening. So, with multiple disks we can say the data transfer rate in case of mirroring cannot be improved, while if we talk about the stripping data across the disk, the data transfer rate can be improved as well. Data stripping consists of splitting the bits of each byte across multiple disks. So, for example, let us say you have one byte to be written, and assuming that you have 8 disks. So, one bit of each and every byte will be written on the first disk, the second bit on the second disk. That means we are going to write bit I of each byte to the disk I, and because of this we can achieve the higher data transfer rate, or the data transfer rate multiplied by the factor of we can say the number of disks whatever we have. So, data stripping consists of splitting the bits of each byte across multiple disks, and such stripping is called bit level stripping. So, in this what are we going to do? We are going to take 8 disks, or we can say an array of 8 disks, which will be treated as the single disk, and these sectors are this array of 8 disks will be treated as single disk having sectors that are 8 times the normal size. So, your access rate we can say, or your data transfer rate is going to be increased by 8 times, because every disk participates in every access, whether it is read access or write access, and because of this each access can read 8 times as faster uh, as on the single disk. Now, in this stripping I have told you that each bit, let us say bit I of every byte will be written onto the disk I. So, this is what you call, we can say, a bit level stripping. Now, apart from bit level stripping, we have other levels of the stripping, which are block level stripping and others. Let us try to consider those. So, first is levels of stripping. When we say bit level stripping, this is kind of, we can say, it is generalized to include a number of disks that are either we can say 8, a multiple of 8, or it is a factor of we can say 8. While if it is not going to be a bit level stripping, there can be blocks. So, one block will be written on one disk, another block on another disk, or we can say ith block on the ith disk. So, in block level stripping we have with n disk, block I of a file goes to the disk I mod n plus 1, we can say. So, if we have 4, then the fifth one will come to the first, and then so on and so forth. Not only the block level and the bit level, there are other levels of stripping, such as bytes of a sectors or sectors of a block are also possible. And block level stripping we can say is the most common, apart from whatever with block level stripping is one of the most commonly used levels of stripping. It is not the bit level stripping, because bit level stripping is we can say at 2 micro level to be handled. Now, we have seen two things. One is the mirroring, another one is the stripping. So, mirroring, as we say, is high reliability, but it is expensive because each and every disk is having its own backup, while stripping is providing us high data transfer rates, but it is not improving reliability in any terms, because reliability will be we can say ensured or improved with the help of redundancy. So, in stripping we have not seen any redundancy, it is just the division of the data to be kind of returned and accessed obviously. Now with mirroring there is reliability but expensive, that is an expensive affair. But with stripping we have high data transfer rates but no improvement in reliability. So there are numerous schemes to provide redundancy at lower cost, and this redundancy at lower cost is provided by using disk stripping combined with parity bits. That is one technique which has been proposed, and all these schemes have different cost performance trade off, and these schemes are classified according to the levels known as RAID levels, RAID, as we have as I have told you in the starting of the lecture. So there are various levels of RAID. One is RAID level 0, then level 1 we have, level 2, level 3, level 4, 5 and 6. These 7 levels of RAID are available. Now let us try to just quickly go through all these levels, that what is actually happening. We will try to see and understand the concept of this RAID level, and then we will be going through the general details of this RAID structure. So basically it is a scheme which is there to provide redundancy at lower cost by using the disk stripping combined with parity bits. So basically your these RAID levels are combination of disk stripping combined with the parity levels. Now if you can see on the screen, we have the RAID level 0 and then we have RAID level 1. So RAID level 0 is actually non-redundant stripping. It is just having stripping. For example, if you can see 4 hard disk symbols in the figure A, or in the figure which is on the top. So we can say stripping is done, maybe a block level stripping. So one block is with block number 1 is with the first disk, block number 2 is with the second disk, and then so on, block number 3 is with the third disk, and then so on and so forth. But that is no redundancy is there. So that's a non-redundant stripping, and this is known as RAID 0. While coming to RAID 1, we can see 4 extra disks which are attached or which are shown in the figure, and all these 4 extra disks are marked as C. So C here stands for the copy. So for example, we have 4 disks here. We are going to make exact replica of those particular disk, and here actually mirroring is happen, a complete mirroring, or we can say a complete redundancy, and this is what you called RAID 1. So in upcoming figures, if we will be having, mostly we will be having 2 symbols. One is C as in copying, when we C as in copy, when we mirror the disk, that is we use the letter C, and when there is a stripping combined with parity bit and we are using these some error correction codes like parity, we will be using the term P. Now RAID level 0, as we have seen, is basically stripping at the levels of blocks but no redundancy, and RAID 0 is taking any number of disks and merging them into one large volume, we can say. It will increase the speed obviously in which the read and write is happening, because this will happen with multiple disks at a time, but all the data will be lost if any one of the disk fails, because no redundancy is being provided, neither the redundancy is being provided nor any parity bit. So in absence of redundancy and parity bits both, there will be no guarantee, or more specifically we can say all the data on the disk will be lost if any one of the disk fails. RAID level 1, as we seen, refers to the disk mirroring. Disk mirroring, as in it duplicates the data across 2 disks in the array, providing full redundancy. So for example, your the data of the disk 1 is being mirrored onto the data of disk 5, the data of disk 2 is mirrored on the data of disk 6, as we have seen that there are 4 extra copies. So, for 4 disks it is having 4 extra copies. So, we can say it is a complete backup, or complete, not backup is not the right term here, it should be mirroring. So, the complete mirroring, because the write is going to be write is going to take place simultaneously onto the both disks. So, read level 1 refers to the disk mirroring, in which the data is being duplicated across the 2 disks in the array, providing complete redundancy, and both the disks store exactly the same data at the same time and at all the times. So, if one data or one particular disk is being we can say crashed, another one can be used in its place. Now, here in as I have told you in upcoming figures, we will be using some more RAID structures, and the two terms here, C indicates the second copy and P indicates the error correcting uh, bits, and the extra some extra disks are used to store the redundant information for failure recovery. Now, with RAID 0 as the non-redundant stripping and RAID 1 as the disk mirroring, let us come to RAID 2, RAID 3 and RAID 4. So, here you can see there are some disks which are going to give us the idea of some parity bits. Parity bits actually belong to error correction codes. So, in RAID 2 we are using some error correcting codes which are memory style error correcting codes. In RAID 3 we are using some bit interleaved parity, and RAID 4 is about block interleaved parity. So, here you can see that there are some disks on which parity bits are stored. So, RAID 2 it is having 3 disks, for RAID 3 it is having only 1 disk, and for RAID 4 it is also having only 1 disk for the corresponding 4 disks. This is what I am talking about. So, yes, here we can say at parity bits at different levels or different style correcting codes are being stored here, and these combinations are forming various levels of RAID, which are RAID 2, RAID 3 and RAID 4. The detailed explanation of these RAID 2, RAID 3, RAID 4 or others upcoming lies beyond the scope of this particular course. Similarly, RAID 5 is having some block interleaved distributed parity, and RAID 6 is a combination of P plus Q redundancy, but we are not going into the details because that is beyond the scope of this particular course. So, here it is we can understand that this RAID structure is kind of an organization or structure in which these disks are being arranged. Either they will be used for mirroring, or they will be used for various levels of stripping, and this is basically there to provide the, we can say, performance reliability. Now, coming to there with this kind of structure, there comes its own benefits and also we can say the disadvantages. So, let us try to understand this RAID as a whole. Coming to the benefits of RAID, we have cost effectiveness because the lower price disk can be used in large numbers. So, the for example, for 4 of the high priced disk, if we need 8 lower priced disks, this can be a cost effective thing if rather than employing another 4 high priced disks. Then improved performance is obviously there because reliability is being ensured, and so as your increased speed of read, increased speed of write, we can say, and also the reliability even after a cache will be crash will be improved because we have some backups or we have some error correcting codes. So, this overall is going to give an improved performance. Also, resiliency has been increased along with the availability, and with mirroring we can say the RAID arrays can have two drives containing the same data, and it will ensure that one will continue to work even if another fails. So, with this increased resiliency, the speed, the performance and the availability, there also comes many of the drawbacks of the RAID. That is, the nested RAID levels are more expensive to implement than traditional RAID levels because they require too many disks. Then the cost per gigabyte of storage devices will be higher for the nested RAIDs because many of the drives are used for the redundancy. Then when it now another situation which is very important here is when a drive fails, the probability that another drive in the array will also soon fails is rises. Why? Because all the drives in the RAID array are installed simultaneously and they are subjected to the same amount of wear and tear, having the same more or the same we can say lifespan or the shelf life. So, when a drive fails, the probability that another drive will also fail rises, or will fail soon will rises, and they would likely result in data loss. So, that point has to be we can say taken care very carefully. There are some RAID levels just for example 1 and 5, although we have not seen them in very details, but they can only sustain a single drive failure. Also, a RAID array is in a very vulnerable state until a failed drive is replaced and the new disk is populated with the data. So, within that particular window, when only one disk is working and another one or another drive has been already failed, the situation is very vulnerable. And when the RAID was implemented, it takes a lot longer to rebuild failed drives because drives have much greater capacity. That means one drive is failed and now we want to replace that. So, in order to replace that, that new drive has to be written with the whole data, and these drives have much greater capacity. So, copying that particular data is a huge we can say task here. So, in this lecture we have seen the RAID structure. What is RAID structure? We have seen mirroring and stripping basics in detail, and then we have also taken a brief look about the various RAID structures starting from RAID level 0 to RAID level 6, and we have seen the benefits and the drawbacks of these. Here is the list of references which is being used for the preparation of lecture. Hope you have enjoyed it. I'll see you in the next lecture. Till then, goodbye. Thank you.